All right, so we're taking a look at today's worksheet on irregular shapes and also revolutions, and we're going to be using some volume when we get there. So, all right, so irregular shape. So remember, we're just going to break down the shape that's composed of multiple shapes into each shape that we're familiar with, find the volumes, and add them together. So we have a triangle, and the first one is the same thing on both sides, right? The height's going to be 3, the base here is 3, and then we have the rectangle. So the area of the triangles, remember, is 1/2 base times height. We're plugging 3 and 3 in for these. And so this is going to be an area of 4.5 for each triangle. And then we have the area of our rectangle, which is base times height. And so this has an area of 3 times 7, which is 21. And so our total area is 4.5 times 2, because there's 2 triangles, plus 21, and that's going to be 30. And in this case, there isn't any units, so we can either just say unit squared, or we don't really have to put units. We could just say 30 in the answer here. And that is our total area again. All right. And we can just say for explain, right? Put down the found the area of the triangle and rectangle and added them together. All right. And our second one, we want to find the area of the shaded region. So same thing, we got the rectangle, the triangle, we're going to go ahead and find the shaded, so we're going to subtract. So remember, the area of the triangle, because it's a right triangle, is 1/2 the leg times the leg. So that's 1/2 of 9.6 times 7.2. And then the area of our rectangle is base times height, or length times width, depending on how you want to look at it. And that's 12 times 21.6. So let me get the calculator out here, guys. Pausing. All right, so the first one, when we do 1/2 9.6 times 7.2, we're going to get 34.56. And that's units squared. And then 12 times 21.6 is, we'll get back to you in a minute there, sir. You go away. 259.2. And then we're going to add those together. So our total, right, 34.56 plus 259.2 is equal to, a drum roll, please. And that's 293.76. Once again, explain how we determined it. Found the area of the rectangle and subtracted of the unshaded triangle. All right. The third shape, we have these lovely 2 triangles here. They do overlap, and then we essentially want to figure out the area for this entire A, B, G, E, F. So what that means for us is A, B, G, E, F is that area. Now the problem we have is if we think of this as 2 separate triangles and we find the area, we are essentially finding the area of this smaller triangle twice. So what we're going to need to do is do the area of the blue triangle. All right, we'll call this triangle 1. So the area of triangle, we'll use the letters ABC. We're going to add to it the area of triangle DEF. And because we'll have counted a section 2 times, we need to subtract away the area of the middle triangle. We'll call that DGC. All right? Pretty sure those are what the letters are. That's it. So we already know the distance from A to D is 4, to D to C is 3, and to CF is 2. So pretty straightforward, guys. The area of the first triangle, triangle ABC, is 1/2 the height, which is 4, times the base, which is 7. So that's going to be 14. The area of triangle DEF, right, is 1/2 the height, which is 2, times the base, which is 5. So this is 5. And then the area of triangle DGF is 1/2. And I believe, I can't see it real well. I'm going to get a little eraser here, is 0.9. So that's 1/2, 0.9 times the base, which is 3. So half times 0.9 times 3 is 1.35. And then we're going to go ahead and just do what we said before, add them together, subtract 1.35, and we'll have our answer. So 14 plus 5 minus 1.35 is equal to our total area. And we get 17.65. And so the area of figure A, B, G, E, F is equal to 17.65 units squared. And then explain how we determine the area. And I think we kind of pretty much did that right up here. So if you want to just go ahead and copy and paste here, if you are so lucky to have that option with a pen and paper, go for it. And we don't want all that. We just want this. Oh, not gonna work. But bringing that right there down, and we're good to go. All right. How do we figure the volume of the irregular shapes? Same thing. We want to think of this in terms of friendly shapes here, and then add them together. In the first one, keep in mind this is almost an entire cylinder, right? We're just missing this much right here. So how much of the cylinder, right, is missing? And if you think about it, it's 360 degrees, right? And we're taking away 90 of it. So we are essentially, or actually the other way around. Although it is our favorite letter, we don't want to see the Z there right now. You go away, right? So 90 out of 360, all right, is essentially 1/4. So I'm missing 1/4 of my cylinder, which means I have 3/4. So we want to just do 3/4 times the volume of our cylinder. So 3/4 times, and then it's pi r squared, area of the base, times the height. So 3/4 times pi times 5 squared, and then times the height, which is 10. It does say nearest whole number, so we can go ahead and do that. Get this guy open here. Calculator. So 3/4 times pi times 5 squared times 10. We end up with 589 to the nearest whole number. And this would be feet cubed. and that is our volume. Okay, the second one, right, we have a prism, and then we have a cylinder being cut out of it. So we want to do the volume of the prism minus the volume of the cylinder. All right, so prism's pretty straightforward. It's the area of the base, right, times the height. So in this case, our base is essentially going to be that rectangle down at the bottom here. Okay, so the volume is going to be length times width times height, and then minus pi r squared h. So the length is 18. You can do better 8 than that. 18 times the width, which is 10, times the height, which is 8, minus pi times the radius, which 4 is actually our diameter. So the radius is 2 squared. And remember, the height of the cylinder is the distance that it travels to go from one circle to the next, which is 18. So we're going to go in terms of pi first, see what that looks like, and then we'll go nearest whole number. So we want to go 18 times 8 times 10, right, which is 1,440, and then minus, and then we're doing 2 squared times 18. This would be in terms of pi, so that's minus 72 pi. So this is actually in terms of pi. We can't subtract because we're treating pi like a variable, but if we are going to, remember we can go up and highlight, so the 1440 minus, go ahead and pick that 72, and then pi, and then we're going to get nearest whole number, so 1,214. And this would be inches cubed. And so that is my total volume. We can put a little V equals here for volume equals. You can also do, when you do that volume equals, we can drop a line down to the last volume equals. That's another way to keep track of our work here. And the last one here, we have essentially two rectangular prisms, right? So we want to kind of think of this as like this extra box on the top. So if we just treat this like a box here, okay, and another one on the top of it. So you can see the first one essentially is this guy right here, right? And then on top of that, we have this secondary rectangular prism on the top. So we're going to do just the two volumes and then just add them together. So we'll go the volume of the right is going to equal the volume of the, we'll go prism 1, okay, plus the volume of prism 2. All right, so here's 1, there's 2, and that's a terrible looking 2, but there you go. So remember, it's just length times width times height because it's a rectangular prism for both. And then we're going to plug in. So the length is 18 times the width, which is 8, times the height of 12. That's the large prism. And we're going to add to that the top one. So the length, now I believe that some of my writing is covering up some of this. So the length of it is essentially 6 centimeters plus the width going all the way back, which is the same as the other one, is 8, and the height is 3. And so we're going to add that together. So we'll do them separately first. So 18 times 8 times 12 is going to give us 1,728 plus, and then 6 times 8 times 3, which is 144. Ooh, excuse me. Thank you if you said bless you. And then we add these together. So we're going to add 2, 1, 6, 7, 1,700, and no, that's not right, 1,872. All right. And this should be centimeters squared. volume cubed. Just didn't finish off the bottom of the tube. Okay. So on the next page here, we're going to be doing some volumes and revolutions. So what we're doing is we're taking a two-dimensional figure, we're spinning it around an axis. So this line stays the same. So if you can imagine kind of like a broken sign here, and if it spins so quick, it looks like a three-dimensional space. So to do this, all we're going to do is do a reflection around our axis that is not moving, and then trace the path the vertices takes. So you can see if I take my rectangular region, okay, and I reflect it over this line, I'm going to create this new shape right here, which just looks like the exact same rectangle. All right. These dots are killing me here. All right. Let me do this better. So it's just a dotted line here. Right here. All right. We get the same rectangular shape. And then all we're going to do is trace the path the vertices take. So this vertex is going to map over here, and it's going to go around in that direction. And then this vertex is going to map right over here. Okay, and we're going to go around in that direction. You can see that as I rotate around, I get a cylinder. Okay, and the same thing is going to happen down on the bottom here. So I'm going to rotate and reflect this shape right here over that axis. So this vertex is going to map right over here, and it's going to spin around and form that top. And then this vertex is going to rotate over there, so it's going to spin around and form that bottom part. And there is our cylinder. Okay, so this one's kind of wider, the other one's narrower. So if I take a triangular region, the same thing's going to happen. This is going to reflect over on the other side here. And then this vertex is going to take this path around here. And you can see that we're essentially going to get a cone. All right. And I'm just going to flatten this out a little bit more. So fix that shape right there. You can see we're going to get a cone. And so the big thing to keep in mind here is this side that doesn't move right here, right, is actually the height of our cylinder. And then this side on the bottom, the side that is moving, this is going to be our radius. And the same thing's going to happen. So the side that doesn't move here is the height, and the side that does reflect over here is our radius. All right. And so the same thing is going to occur with this triangle. You can see we're going to reflect it right over that line. So we're going to get this triangle over here. This vertex is going to map to that corner. And so we get our little cone again. And we can see that this side here is our height. And the side that does move is our radius. Okay, a couple other examples. If I take a circle and I rotate it around, so I do my reflection, and then we can trace the path here, you can kind of see that I'm going to get this, looks like a ring here, like a three-dimensional ring. All right, and if I take, kind of looks like half a washer, and we rotate it around, right, we are essentially going to get this three-dimensional sphere. So it's going to look like it's closed, but it actually has a hole right in the middle. So if you were to look inside, there would be an open hole here. All right. And then we could figure out the volume, which is what we're going to do. So for number 6, we have a 3x5 rectangle. So there's 3 by 5. And we're going to rotate it around the side that has a length of 5. So this side is not going to move. Okay, that's going to stay still. So we want to remember reflect it over. Okay, it's going to come down here. And we know when we trace the path, we're going to get ourselves a cylinder. Okay, and we want to find the volume and surface area. So volume of a cylinder is pi r squared h. Remember, the r is the side that moves, so that's 3. So 3 squared, and then times the height, which is 5. So 9 times 5 is 45 pi. It doesn't say what to round to here, so we're going to leave it in terms of pi. And then the surface area, if you guys remember when we cut open, right, our cylinder, we're going to get this rectangular shape and then the two circles. So remember, the rectangular shape is the circumference that goes around the top, and then the height, that's supposed to be a C up there, by the way, guys. So the circumference at the top, and then the height. So the lateral area is 2 pi RH plus the area of the two circles, which is 2 pi r squared. So the surface area is 2 pi. The radius, if you remember, is 3. The height is 5 plus 2 pi times the radius again is 3 and then squared. So we'll just combine some like terms here. This is 15 times 3, which is 30 pi, plus 2 times 3 squared is 9, is 18 pi. And then we are essentially just going to add those together, and we should get an answer of 48 pi. I'm just going to clean this 3 up real quick. And so the surface area is 48 pi, and then unit squared. All right. So a 3 by 4 by 5 right triangle is revolved along the leg of 4. So if we take a 3, 4, 5 right triangle, our axis is essentially this line right there. And we're going to reflect it over to the other side. You do a better job of that though. And we're going to trace the path, and we're going to get ourselves a cone. All right. And so the volume, remember, it's just like a cylinder, but it's 1/3 pi r squared h. All right. So 1/3. Remember, the radius is the side that's moving, so that's 3. And the side that stays the same is 4, that's the height. And we're going to go ahead and multiply that out. So 1/3, essentially 9 is 3, 4 is 12 pi, and that's units cubed. And then the surface area, remember pi RL is the lateral area plus pi r squared, which is the area of the base. So the surface area formula, I'm just going to plug in, is pi times the radius, which is 3. This time the slant height is the height going down the side of the cone here, which is 5. All right, plus pi times 3 squared. And so our surface area becomes 15 pi plus 9 pi, and that is 24 pi. All right. So for part A, we're going to go ahead and take this rectangle, and remember we are going to essentially reflect it over to the other side, and then we're going to trace the path of the vertices. So here, we're going to get this, all right, and then a solid rotation here. So we're essentially getting a cylinder, right, with a hole inside of it. Easy enough, right? So if we wanted to, right, here's our hole right here, okay? I'm not going to darken the whole thing in though, but we want to essentially just find the area or the volume of the two cylinders and then subtract them, okay? So we'll do the volume of the small cylinder. I'll go down here. Volume, small cylinder, all right? And that's pi r squared h. So pi, the radius really is just 1 unit out, so 1 squared. And the height is just 1, 2, so 4 to 1. So that's 3. So this is 3 pi for the volume of the small cylinder. All right, on the other side, we have the volume of the big cylinder, which is once again pi r squared h. So pi, this time the radius goes from, now be careful, it's the big cylinder. So it goes all the way out to here, right? So the radius is actually 3, okay? 3, going all the way out. 3 squared. and then times 3, because the height is also 3. And so this is 3 times 3 is 9, times 3 is 27 pi. So that is the big cylinder. And then the total area or volume, right, is 27 pi minus 3 pi. And so that's 24 pi. And once again, that's units cubed if you need it. All right. We're going to go ahead and I'm going to give you two things. Number one, I'm going to tell you that that unit right there is 2.5 on the x-axis. And the second one here is 4.5. So we're going to use those for our radii here. So just like we talked about on the last page, when I reflect or rotate this around here, we're going to get this sphere, right, with a hole in it. So just right here, you see the last one. All right. So as I rotate this around, you can see that this is going to go here. All right, doesn't have to be perfect, but sphere with a hole. So we just want to do the area, the volume of the two spheres, and then subtract. Okay. So the volume of the small, let's call it little sphere. All right, is 4/3 pi r cubed. So 4/3 pi, and this is 2.5 cubed. All right, so we'll leave it in terms of pi again. So we have 4/3 times 2.5 to the third, and we get 20.83 repeating. So 20.83 with a hat on it, pi, and that is the little sphere. And then we have the volume of the bigger sphere. And so same thing, this is 4/3 pi, and this time it's times 4.5 cubed. All right, so and then we're going to do the same thing. So I'm just going to go up and highlight the last question and then just change this from 2.5 to 4.5. And so I'm going to get 2, now careful, because I cubed the whole thing instead of cubing just the 4.5. So I'm going to go back in front here and put a parenthesis in there. And so I get 121.5 pi. All right. And then we're going to subtract. So the total is 121.5 pi minus 20.83 repeating pi. Now we can subtract these because they both have a pi, which is going to basically leave a pi in our answer. So I'm going to go up and highlight the 121.5. I'm going to subtract out the 20.83 repeating. And I'm going to get 100.6 repeating pi. So 100.6 repeating pi. Now, curious to know, if I subtracted the 4.5 and 2.5, if I would get the same answer, which we don't. So you can't just do like 2.5, right? And 4.5, the difference there is 2. So if I did 2 cubed, like it doesn't work that way because we're cubing them. We have to actually do the numbers and expand them out. But that is the answers to that one, guys. So that is your homework to finish up. And I will see you guys on Wednesday for your partner quiz. All right, guys, have a great day.